Unit 3. The main objective of Unit 3 is to learn the design and realization of sequential circuit design. From the third unit, now we are going to discuss about pipelining. What is pipelining? Pipelining is a design technique used to accelerate the operation of the data paths in digital processors. As we have discussed that pipelining have 3 stages pipelining and 5 stages pipelining. Here the concept they are using only the 3 stages pipelining. We know that fetch, decode and execute. The same principle here they are going to compute. One of the example and the reference circuit they have given to compute log modulus of A plus B. In the diagram there is a 2 registers A, B represent the stream of numbers. Here the registers are edge triggered D registers. So the minimal clock period T min is T C minus Q plus T PD plus T setup. Here T C minus Q is a propagation delay. T PD is a worst case of combinational circuit. T setup is a setup of registers. The delay is generally larger than the delays in registers and dominates the circuit performance. Here they are telling that logarithmic function is larger than the registers. If each logic module has an equal propagation delay, then each logic module is then active for only 1/3 of clock period. Here they are given as a, from the registers they are given as a clock period. For clock period the cycle has continues that 1/3 means the adder circuit is active. If the clock period is 2/3, then it remains the ideal. The mainly it is going to be used for the adder only here. So the clock period it can generate only up to that 1/3 clock period, right? Here the next slide, the pipelining is a technique to improve the resource utilization and increase the functional throughput. Here the number of registers they are using in between the logarithmic function. So here they are easily used to compute the log modulus A plus B. So use registers between the logic blocks. The computations for one set of input data to spread over a number of clock periods. The result for the data set A1 plus B1 or A1 comma B1 only appears at the output after 3 clock periods. At the time the circuit has already performed parts of the computation for the next data sets A2, comma B2 and A3, comma B3. So the advantages of the pipeline concept is a minimum clock period they are using it. The combinational circuit block has been partitioned into 3 sections, each of which has smaller propagation delay than the original function. The minimum allowable clock period is T min is equal to Tc minus Q. So we have discussed this as a propagation delay plus max in the bracket TPD at comma TPD ABS comma TPD log. So all the TPD is a fully a worst case of the combinational circuit. So first thing they are using a activating the clock cycle, so adder is using that, and afterwards it is a absolute value, next logarithmic value, so that we are getting the final value as a logarithmic of modulus A plus B modulus. Finally, the register's overhead is small with respect to the logic delays. The performance is a high data paths. The next slide is latch versus register based pipeline. The pipeline system is implemented based on pass transistors based positive and negative latches instead of edge triggered registers. Previously, all the registers we have used as edge triggered registers. Now we are going to use as positive and negative latches. Logic is introduced between the master and slave of a master-slave system. When the clocks CLK and CLK bar are non-overlapping, correct pipeline operation is obtained. Input data is sampled on C1 at the positive edge of the clock, and the computations of logic block F starts and is stored on C2 on the falling edge of the clock. The computations of logic block G starts. The value stored on C2 at the end of the clock low phase is the result of passing previous input through the logic function F. When overlap exists between clock and clock bar, the next input is already being applied to F, and its effect might propagate to C2 before CLK bar goes slow, so that the pipeline operation is not working correctly when it is goes slow. If it is goes slow, low operation, the pipeline operation is not obtained there. If it is not overlapping, that is the high state, so the correct pipeline operation is obtained. So this is the main concept of pipelining. How, first thing, how it compute the log modulus a plus b. The next, how the master slave operation, the pipelining is performed here. Thank you.